Welcome to a new episode of Médecine in 30 minutes. As usual, we go straight to the point. The subject is bravely made clear and often illustrated. Let's start. Today's topic is embryonic development. Here is the plan of the presentation: fertilization, zygote, cleavage, differentiation, blastulation, gastrulation, neurulation, and clinic repercussions. Here is an anatomical reminder of the fallopian tube: fimbria, infundibulum, ampulla, isthmus, uterus, and ovary. What is the fertilization? Fertilization involves the fusion of male and female gametes to form a zygote. The fertilized ovum with fusion of two nuclei become diploid cells with 46 chromosomes. It is a zygote. Once the zygote starts dividing, it is called an embryo. During its development, the embryo grows and migrates in the same time. Week 1, zygote. Week 2, bilaminar blastocyst. Week 3, trilaminar tri-layer forming. Week 1, post-conception. Ovulation in the 14th day, and then there is fertilization and implantation. Fertilization is intratubal. Implantation is intrauterine. We start with zygote, morula, and blastula before implantation. Fertilization: day 1, zygote. Day 2, 2 cells blastula. Day 3, 4 cells blastula. Day 4, morula. Day 5, blastocyst. And day 6, blastocyst. Cleavage. Cleavage is to divide, split in 2 cells without growth. It giving 4 cells, 8 cells, and 16 cells. At 32 cells, a new name is given: morula instead of zygote. Morula instead of zygote. There is no zone pedicella more. Compaction. Within the morula, the cells stick together. Cells become closer. It's a compaction. Differentiation. Within differentiation, there is 2 populations of cells. Outside cells are trophoblastic, and inside cells are embryoblasts. Differentiation: outside is trophoblast, inside is embryoblast. Blastulation: cell cluster at the end, inner cell mass is forming, and cavitation as a blastocele. After cleavage, the whole process is blastulation. Inner cell mass, the embryoblast become inner cell mass, and there is a cavitation, which is the blastocele. All process is blastulation. Another cavity developed called amniotic cavity. Inner cells differentiate more to hypoblast and epiblast. The zona pellicida disappear completely to prepare for the implantation. The structure is spherical like a melon. A surface is like a pancake with a flat surface. The dimension image, the 3 dimensions image show epiblast and hypoblast like a bilaminar disc. Gastrulation. Within the bilaminar disc, there is cell migrate from the primitive as a primitive strike. Instead of having 2 layers, epiblastic and hypoblast, we have 3 laminar discs called germ layer. Epiblast become ectoderm, middle layer is mesoderm, and lower layer is endoderm. The process of 3 layer is called gastrulation. Bilaminar disc to 3 laminar disc. The bilaminar disc will convert into 3 laminar disc. Layer toward the amniotic cavity is ectoderm. The layer toward the yolk sac is endoderm, and the layer in between is mesoderm. Ectoderm, mesoderm, and endoderm. And within the mesoderm, something starts to appear. It's notochord. The upper layer or epiblast and lower layer or hypoblast are held together tightly. They fuse in a point of hypoblast on the derm called prochordal plate. We identify for the first time the cephalic part of the embryo, its future mouth and future head. Notochordial process and precordial plate. Neurulation. In the middle of the mesoderm, cords start forming notochord. Its main purpose is the neurulation and to differentiate in mesoderm, inducing change and thickening of the ectoderm above it. The neuroplate evolves into neurotube. Neuroplate cells start to dive in the mesoderm, forming a ring section of a tube called neural tube. Little cells are breaking off from the ectoderm going to the mesoderm. They differentiate to their own tissue as neurocrest cells. Neuroplate evolve into neurotube. The notochordal tissue, ectoderm above the notochordal tissue, rapidly proliferate to make an additional layer of longitudinal thickness called neural plate. Next, the neural plate starts depressing down and folding to form the neural groove. In the future, the neural fold will keep on elevating until they fuse with each other to make the neural tube. Some cells will separate from the neural tube to form the neural crest, which are the precursor of peripheral nervous system. Ectoderm, neural tube, and crest cells. The neural tube is the precursor of brain and spinal cord. The notochordal canal is the precursor of nucleus pulposus in vertebra. The anterior neuropore close and 25 days of gestation, and the posterior neuropore and the 28 day with which the neurulation is complete. Around this time, every woman should have implement of folic acid in her blood. All female in reproductive age should have a good amount of folic acid in her blood. If there is a deficit in folic acid, the anterior neuropore will not close, leading to anencephaly, which is not compatible with extrauterine survival. Posterior neuropore, on the other hand, may not close properly, leading to spina bifida. Fertilization involves the fusion of male and female gametes to form a zygote. Week 1 post-conception, zygote, morula, and blastula. There is a fertilization intratubal, and there is implantation is intrauterine. Day 1 zygote, day 2 2 cells blastula, day 3 4 cells blastula, day 4 morula, day 5 blastocyst, and day 6 blastulation, end of blastulation. Cleavage is to divide and split into cells without growth. At 32 cells, a new name is given, morula instead of zygote. With morula, the zone pellucida disappears. Compaction. Within the morula, the cells stick together, cells become closer, it's compaction. Differentiation. Two populations of cells, outside is trophoblast, inside is embryoblast. Blastulation is the formation of blastose cell. This cavity is the blastocell, and these cells are inner cell mass. When a second cavity develops, called amniotic cavity, there is differentiation between hypoblast and epiblast. We are at the stage of bilaminar disc. When we move from bilaminar disc to trilaminar disc, it's gastrulation. There is the primitive strike appear, and there is ectoderm, mesoderm, and endoderm. Ectoderm, mesoderm, endoderm, and notochord. Precordial plate will identify for the first time the cephalic part of the embryo, its future mouth and future head. Ectoderm above the notochordal tissue rapidly profilate to make an additional layer of longitudinal thickness called neural plate or neuroectoderm. Next, the neural plate starts depressing down and fold to form the neural groove, and then the neural groove forms the neural tube. Ectoderm, neural tube, crest cells. The neural tube is the precursor of brain and spinal cord. The notochordal canal is the precursor of nucleus pulposus. Anterior neuropore close at 25 days of gestation, and posterior neuropore close at 27 days. Around this time, every woman should have implement of folic acid in their blood. All female in reproductive age should have a good amount of folic acid. If there is a deficit of folic acid, anterior neuropore will not close, leading to anencephaly, and posterior neuropore may not close, leading to spina bifida. Thank you for watching this episode of Medicine in 3 minutes. Would you like to click the button like and subscribe? Your comments are very welcome. Thank you.